Now we shall try to minimize this DFA. This is the DFA, okay, and that is the table which I have formed from this DFA. So let us assume that this is the equation given, or you can even assume that is the equation given. Both are same. This is the state transition diagram and this is the state transition table. If any state transition diagram is given, then better you convert it to state transition table, because minimizing from table is easier compared to minimizing from the diagram, or you can go in any way you can want. Now first of all, you have to observe one thing. First thing is, if there are any states which are not reachable from initial state, you remove them. Let's take Q1. Is it reachable from initial state? Yes. Let's take Q2. Yes. Let's take Q3. Q3, there is no way anyone could reach Q3. Therefore, I am going to remove Q3 and all the transitions incident on it directly. I am going to remove Q3. So Q3 is not going to be there in the final answer. Now, what about Q4? Is Q4 reachable? Yeah, I think Q4 can be reached via Q6. And what about Q5? Is Q5 reachable? Yes. What about Q6? Yes. What about Q7? What about Q7? Yeah, it is reachable via Q4. Yes. So everything else is reachable. Only state which is not reachable is Q3, and it has been removed. Now, what is the initial state? Q0. What is the final state? Q2. So just for the sake of convenience, mark Q2 wherever it has occurred. Q2. Okay. Now I am going to erase this and we shall work out with that table. It is no longer required. Once you have designed the table, state transition table, diagram is not required. Okay. So first step is, you have to find zero equivalent states. What are the zero equivalent states? It is nothing but divide entire states into two groups. One group should contain all non-final states and other group should contain final states. Zero equivalent is nothing but Q0, Q1, Q4, Q5, Q6, Q7. Q0, Q1, Q4, Q5, Q6, Q7, and Q2 is the final state. Just separate them. Next thing is, you have to find one equivalent. In one equivalent, you have to find out whether these zero equivalent states are still going to remain in the same group in the one equivalent or not. Those who remain in this same group are said to be equivalent. Now let us compare Q0 and Q1. Q0 and Q1, these two. Q0 and Q1 on 0 are going to Q1 and Q6. Q1 and Q6 are in the same group, therefore it is not a problem. It is not creating any problem. Now see this. On 1, Q0 is going to Q5 and Q1 is going to Q2. One is going to non-final, other is going to final. So Q5 is here and Q1 is here. So whenever they go to different groups in the previous equivalence, they are no more equivalent in the current equivalence, which means Q0 is separated from Q1, and I don't know who are going to join Q0 or Q1. Let's check it later. Okay, fine. So we have checked Q0 and Q1. Next thing is, check Q0 and Q4. Let's take Q0 and Q4 and check it. Q0 and Q4, these two. Okay, so Q0 on 0 is going to Q1 and Q7. Q1 and Q7 are in the same group. See, don't see this when I am discussing about one equivalent. Don't see the partially formed groups of one equivalent. When we are working on one equivalent, we will always be working from zero equivalent and this table. Now if you see Q0 is going to contain Q0 and Q1, and see Q0 and Q4 are going to Q1 and Q7. Q1 and Q7 are in the same group, and Q5 and Q5, obviously Q5 and Q5 are in the same group because they are the same state. Therefore Q0 and Q4 are one equivalent. Next let us say Q5. I want to check Q0 and Q5. So if you check Q0 and Q5, it is Q1 and Q2. It is Q1 and Q2, different groups. Therefore Q5 is not equivalent with Q0. So Q5 I cannot write it here. Now let me check with Q1. Let me check Q1 and Q5 so that I'll see whether they can be written together or not. I'm checking Q1 and Q5. Now if we say Q1 and Q5, they are Q2 and Q6, Q6 and Q2. Q6 is here, Q2 is here. Therefore, it is not even equivalent with Q2. So Q5 is going to be a separate state. Why? Because it is not equivalent with Q1 or it is not equivalent with Q1, Q0 or Q1. Now let us say Q6. What about Q6? Let us check Q0 and Q6. Q0 and Q6. You need not draw the lines to do this. I just wanted to explain you so that I am drawing the lines. You should be able to directly look into the paper and then using fingers you should be able to do it. Don't draw the lines. Okay. Q0 and Q6. They are going to Q1 and Q6. Yes, Q1 and Q6 are in the same group. And Q4 and Q5. Yes, Q4 and Q5 are the same group. Don't look at this group, this one. Look at this one only, right? So since they are in the same group, they are equivalent. So Q0 and Q6 are equivalent. Therefore, I am going to write it in the Q this one. And next one is Q7. Let me compare Q1 and Q7. Q1 and Q7. If you see it, Q0 and Q7, they are going to Q1 and Q6. Q1 and Q6, that is fine. But Q5 and Q2, which are different, therefore it has to be separated. So Q0 and Q7 are not equivalent, so I should not write it in this group. Let me check it with Q1 once. Now let me check Q1 and Q7. Q1 and Q7. Just see this. Q1 and Q7 are going to Q6 and Q2. Same states, therefore they will always be equivalent. If they are going to go to same state, they will always be equivalent. So Q1 and Q7 are always going to be equivalent, and Q5 is going to be alone. See this? So in the first zero equivalence, we got two groups, non-final and final. In one equivalence, we got four groups, 1, 2, 3, 4. And in the first one, it is going to contain Q0, Q4 and Q6. It means that all these three states are one equivalent. It means that all these two states are one equivalent. What does this mean? If you give any string of length 1, all these states either go to accepting state or go to non-accepting state. These two states, if you give any one length string, either they will go to non-accepting state or accepting state. Now let's talk about two equivalent. See, whenever you find any group with a single element, you need not process it again because we cannot separate them. So they are already separated. Okay. Now let us see this one, Q0 and Q4. Let us compare Q0 and Q4 to find out if they are two equivalent or not. Q0 and Q4. Right. So if you look at them, they are Q1 and Q7. They are going to Q1 and Q7. So Q1 and Q7 are in the, oh, you have to look at this. Q1 and Q7 are in the same group, no problem. And Q5 and Q5, obviously the same state. So see this, Q0 and Q4 are going to Q1 and Q7. So when you are talking about two equivalent, you have to look at only one equivalent. You have to look at only this one, not the previous one. Okay. Now if you see Q0 and Q4, they are going to Q1 and Q7, no problem, they are in the same group, and Q5 which is in the same group. Therefore Q0 and Q4 are equivalent. Now let us see Q0 and Q6. Q0 and Q6. Right. So Q0 and Q6 are going to Q1 and Q6. So Q1 and Q6, obviously they are from different groups in one equivalent. Therefore Q6 has to go out. Now let us compare Q1 and Q7. If I compare Q1 and Q7, they are going to same state. See, Q6, Q2, Q2. So they can never be separated. They are always equivalent. Couple for life. Okay, fine. And now let us talk about three equivalent. In order to talk about three equivalent, we have to look at two equivalent only. So don't go to 1 equivalent or 0 equivalent, just look at this one and you have to answer it, right? Let us see if Q0 and Q4 are equivalent or not. If in order to check for Q0 and Q4, Q0 and Q4, Q0 is going to, Q0 and Q4 are going to Q1 and Q7. Q1 and Q7, they are in same group. Q5 and Q5, Q5 and Q5, they are in the same group. Therefore, they cannot be separated here also. So Q0 and Q4 are even 3 equivalent. And this is already same. And Q1, Q7, I have already told you that they are coupled for life, because they are always going to same one. See this, Q1 is going to Q2, Q6, and Q7 is going to Q2, sorry, Q7 is going to Q6, Q2, Q6, Q2. They are always combined, they can never be separated, right? And even if you go for 4 equivalent, you will get the same. See, if 2 equivalent and 3 equivalent is same, even if you go for 1 more, you will get the same. Even if you go for 5 equivalent, you will get the same. Even if you go for infinity, they will get the same, which means for every possible input, Q0 and Q4 are going to be in the same state, Q6 and these are going to be in same state. So in the initial diagram, if there are 8 states, the minimal DFA will contain 1, 2, 3, 4, 5 states. So we have minimized the DFA from 8 states to 5 states. This is the answer. And let me construct the DFA and even show you this. So if these are the final number of final states in the DFA, let me show you the DFA itself in terms of state transition diagram. So state transition diagram is going to look like this. Q0 and Q4. Q0 on 0 is going to Q1. So that group is Q1, Q7. Q1, Q7. They have to be together, right? So Q0 on 0 is going to Q1. And Q0 on 1 is going to Q5. This is 0, this is 1. And Q1 on 1 is going to Q6. Now Q1 and Q6, see this Q1 and Q7, Q1 on 0 is going to Q6, okay, and Q1 on 1 is going to Q2. Let us write Q2 somewhere. So where is Q2? The final state, it has to be somewhere. So Q2 is the final state. So Q1 on 1 is going to Q2. Now next one is, see, I think we have to get 1, 2, 3, 4, 5, 6 states. In initial there were 8 states and we have to get 6, which means Q0 and Q4 is combined and Q1 and Q7 are combined. Therefore the answer has to be 6 states, not 5 states. 1, 2, 3, 4, 5, 6. You have to even include Q2 also. I forgot to include it. Okay. Now this one is complete. This one is complete. Now let's see Q6. Q6 on 0 is going to Q6 and Q6 on 1 is going to Q4. If it is going to Q4, it will go to Q0 and Q4. Next, this one is complete. What about Q2? Q2 on 0 is going to Q0 and Q2 on 1 is going to Q2 itself. Next one, Q4. Q4 on 0 is going to Q7, yes, and Q4 is done, because see, once if I are done with Q0, Q4 is the same, and once you are done with Q1, Q7 is the same, right? So next one is Q5. Q5 on 0 is going to Q2 and Q5 and 1 is going to Q6. So once you are done with Q0, you need not write again for Q4. Once you are done with Q1, you need not again do it for Q7. So this one is complete, this one is complete, this one is complete, all are complete. So this is the final diagram. So how many states did we get? 1, 2, 3, 4, 5. I think one more state should be there, 6. So is there any state missing? Q0, Q4, Q6, Q1, Q7, Q5, Q1. Oh, it has to be Q2, it is not Q1. Fine. So it is just 5 states, not these many states. Okay, so this is the final answer.